Okay, in this video I'm going to talk about the incenter of a triangle. So basically this is the center of the inscribed circle. So incircle, circle that touches all sides or is tangent to all sides of the triangle, and it is also the center I, and it is also the intersection point of the bisectors. So in particular we have theorem that says that the bisectors of any triangle, intersect at a single point and this point is the center of the incircle, and this point is the center of the incircle, the inscribed circle. So let's prove this. So we know that a bisector of any angle is the locus of points that are at the same distance from the sides of this angle, right? So these distances are the same, and this is because simply like these two triangles. So this is a bisector. So these two triangles are equal to each other by the side. So they have a common side and two angles. So basically all three angles, basically, because this angle is right angle. It's of course equal to each other. Then this is equal because it's the bisector, and the third angle is simply calculated as 180 degrees minus the two other angles, so it's also equal. So this angle is also equal. So all three angles are equal and they have a common side, so these two triangles are equal, therefore the distances are the same. So now what we have in a triangle is so let's take first two bisectors without considering the third one for now. So this is a bisector and this is a bisector. So what is this point? So this point is at the same distance from this side and from this side, because like from what I just proved. But on the other hand, so this is because it lies on this bisector, right? But because it lies on this bisector, on the other bisector, it is also at the same distance from the two other sides, so from this side and from this side, right? So like if we denote this distance as h1, h2 and h3, so A, B, C. So because So this point like denoted by I. So because we don't know, well, maybe it's not good to denote it by the same letter as the incircle, so we don't yet know if it's an incircle, so let's denote it by X. So the intersection of these two bisectors. So because X belongs to the bisector of the angle A, it follows that H1 is equal to H2. So let's so this is H2 and this is H3. So because X belongs to the bisector of the angle C, it implies that H2 is equal to H3. So from these two properties, now we conclude that, so from this and from this, we conclude that all three of them are equal to each other. And in particular, that H1 is equal to H3. And H1 and H3 are this. So from this it implies that it belongs to the third bisector, because the locus of the points that are at the same distance from the sides of the angles of an angle is exactly the bisector of this angle. So from this it implies that X belongs to the bisector of the angle B. So we started with the point that is the intersection of two bisectors, and we proved that the third bisector also passes through this point. Therefore, these three bisectors, so X belongs to all three bisectors, so all three bisectors intersect at a single point. Now notice that why is it the center of the incircle? So notice that we have this. So all three distances from this point, from this intersection point of the bisectors to the sides, are equal to each other. But this is by definition means that if we consider a circle, so consider a circle with center X. Well, now we can denote it by I. Well, okay, we already have X, it doesn't matter. So center X and the radius equal to this H1, H2, and H3. So it is equal to H, which is like H1, H2, and H3. So we denote it denoted by H, a single letter. So then by definition, so not by definition, but by the property that a line that is perpendicular to a radius passing through. So if we have a circle and a point on the circle, and we have a line that is perpendicular to the radius at this point, then it is a tangent. So there is such a property. So so because of this, we have that all three sides. So then then these altitudes from this point x to the sides, these are radii of this circle, right? Of this circle, and then because it is perpendicular, so then it is a tangent. So AB, BC, and CA are tangents to this circle. And then by definition, this is the incircle of the triangle ABC, because it is tangent to all sides of the triangle. So this is exactly the definition of the incircle. And so we proved that the intersection of the bisectors, it is the center of the incircle, so it is the incenter. So this concludes the proof.